Let's talk about intersection and union of two sets. Now, for this one, we have 6 elements of set H. Okay, and then 4 elements of set L. So there are two sets, and we are supposed to find the intersection and the union of the two sets. Okay, so intersection is denoted by that symbol there, that upside down U, I guess. And the intersection of two sets means what they have in common, only what they have in common. Well, they both have a -2. So we'll stick that in there. Anything else? Let's see. They both have a 5. Okay. And that's it. So that would be the intersection of the two sets, just what they have in common. Now, the union, that's going to be denoted with a U. So the intersection symbol flipped over. That's all. It's not especially creative. The union is just everything that's in the two sets. Okay, so the easiest way for me to do this is just take the first set and write everything down. Okay. And now I'll grab everything from the other set that I have not yet written. I've already written -2, so I don't need to put it again, but I do need to include that 0 and the 4 from set L. And I've already written the 5 right there, so I don't need to do it again. And there's my set for the union. So the basic idea of intersection and union is, with intersection, you keep only what they have in common or where they overlap. And union, you keep everything from the two sets. Now let's do this again, only this time, instead of giving us individual elements or numbers or whatever, they're giving us intervals. So I think what might be helpful, and you don't have to do this, but what might be helpful is to write out these intervals on number lines. So this first one says D is the name of the set, and set D is all numbers Z, and that's not a big deal. All numbers that are greater than or equal to 2. So on a number line for D, for set D, if I put a 2, say right there, all numbers that are greater than 2 or equal looks like that. Now we contrast that with set E, which is all numbers that are greater than 6. So if I draw set E down here, and I put the 6 there, and you'll notice that the 2 is to the left of the 6 because 2 is smaller than 6. So I did that on purpose. So all numbers greater than 6 is going to be bigger than 6. Now this time we're not going to include 6, so I'm going to do an open circle. Okay, because I don't have the or equal sign down there, just like I did on the first one. Okie dokie. So what would be the union and intersection of these sets? Well, the union, the stylus is not working well. The union is going to be everything that's shaded. Keep it all. If it's shaded, we keep it. Well, if I pick up, for example, if I pick up that number line and I drop it on top of this one, everything that would be shaded would be everything from 2 on over forever. So it would be all numbers, that are 2 to infinity. That would be one way to write it. That's interval notation. The other way would be all numbers, and they're using Z, so I'll use Z, greater than or equal to 2. And that would be inequality notation. Okay, so what about the intersection of the two sets? Well, intersection is only what they have in common. And if I pick up one of them and I drop it on the other, the overlap, the part that they have in common, is only going to be from there over. Okay, so that would be just everything from 6 on up. Or in other words, all numbers greater than 6. So you'll notice if there's no or equal sign there, then I use a parenthesis on the number. But if there is the or equal sign, I use this squared off bracket. And that is how we do it. Now for this one, we're supposed to solve that inequality and that inequality. Okay, so, well, let's do it. So the first one, I think I'm going to work on the left side of the screen, I guess. So 4x minus 5 is less than or equal to 3. So I'm going to add 5 to both sides. And that'll give me 4x is less than or equal to 8. Then I divide by 4. And x is less than or equal to 2. Okay, cool. Now the other one. Let's go this color again. So 3x plus 1 is greater than or equal to 19. And if I subtract 1 from both sides, I get 3x is greater than or equal to 18. Then I divide both sides by 3, and x is greater than or equal to 6. Okay, but what's the solution? If I were to graph this thing, what would it look like? Well, I know what x is less than or equal to 2 looks like. Okay, that looks like that. And I know what x is greater than or equal to 6 looks like. That looks like that. Okay, but that's two different graphs. I want a single graph for my solution. So how do I combine them? Am I going to combine them with intersection, or am I going to combine them with union? Well, the key is right here. The word or. Or means union. That's what it means. Okay, so or means we're going to do the union of the two sets, and union means just keep everything that's shaded in between the two of them. So so our graph would look like this. Okay, that would be the solution. If we wrote that in interval notation, it would look like this. Everything from negative infinity to 2, union, because our solution set comes in 2 pieces, so we connect the 2 of them with a union. And then 6 to infinity. And that would be how you would write it in interval notation. They don't ask us to do that, but they will eventually, pretty soon. But this is the solution that they're looking for. Now, what if it was not an or? What if it were an and? Okay. Well, then, if it were and means intersection. Okay. And so we would say, oh, what's the intersection of these two sets? Where do they overlap? If I pick one of them up and dump it on the other, where do they overlap? Well, they don't. The two shaded regions would not overlap. So in this case, if it were and, our answer would be no solution because they don't overlap. So union, or I'm sorry, or means union, and means intersection. And so that's how you handle those guys as they appear. Okay, now they say, okay, do it again, same thing, but this time with interval notation. So, all right, whatever. So I will solve both of them and say, all right, let's divide by -4 to get the variable by itself. And watch closely because the hand is quicker than the eye. -4 divided by -4 on the right is going to give us +1. But in an inequality, when you multiply or divide by negative, you flip the inequality symbol. Ooh. Okay. And then we've got and because, well, it says so right there. And then on this one, we're going to add 2. I know it's doggone, that's hard to write. And then we get 3w is greater than or equal to 12. And I'll divide by 3. And I don't need to flip the inequality because I'm not multiplying or dividing by a negative. And I get that. Now, at this point, you don't have to draw the number lines, but I think it just makes it easier to tell what's going on. So the first inequality says all numbers less than or equal to 1. At least I think that's what it says. Yeah. And then the second one right there says all numbers greater than or equal to 4. Now this time it is and. And means intersection. It means just take what they have in common. And these two, if I pick one of the intervals up and or number lines up, dump it on the other, then the shaded regions will not overlap. They have nothing in common. So the answer would be no solution. Okay. Now, what if, just, because it's fun to say what if we had something like this? Oh, wait, I need to click on that again. What if it had been less than or equal right there? How would that have played out? Well, let's see. We would have had a shaded circle because of the or equal, and less than means shade where numbers get smaller to the left. And the and would mean take only what they have in common. So if I pick one up and dump it on the other, then I'm going to get that what they have in common is from there over. And in which case our answer as a graph, which is not what they asked for this time, but our answer as a graph would be that. Now they said, give me interval notation. Okay, so that would be everything from 1 to negative infinity. If that inequality sign had been like that, which it was not. And that's what we do.